Hello everyone, this is Physics 103 on atomic structure, and in this lesson we are going to learn about the spin quantum number. Okay, so before we actually talk about the electron spin and spin quantum number, let's give sort of a motivation where this spin actually came from. So from the previous lessons, we have we have shown that Schrodinger equation only gives three quantum numbers Nm, Nl, and Ml. And from the Zeeman effect, or rather the anomalous Zeeman effect and the Stern-Gerlach experiment, we have seen that the spectral line splitting should give a value that is odd, but for a given value of L equals 0, 1, 2, and so on. But in experiments, they observe even. So there is a big question mark in these even numbers. And this is a major motivation for introducing the electron spin. So let's analyze this rule. So 2L plus 1. So for this to have an even number, let's have an hypothetical number j. This should be some fraction, some half integer value. So for example, 1 half, 2 times 1 half would be 1 plus 1. This will be 2 even. This can be 3 halves. This can be 5 halves. So the only way for this to be even is to have even number of half integer na number of j. So this is just a motivation. So they cannot understand why this electron forgive me for the analogy of electron spinning, but we don't have actually a picture of how electrons behave in an atom, but for the sake of analogy, so this electron is actually spinning in this hydrogen atom, and it is producing a magnetic moment mu that is arising from this kind of rotation. So two physicists, graduate physicists, Samuel, let's just call Samuel Goldsmith and George Uhlenbeck. These two physicists proposed that the electron, they proposed this should have some sort of additional motion. So instead of it just moving around in this manner, they said that this electron actually may be moving in this direction or in this direction. So they proposed that this electron will have a magnetic moment, or sort of a spin, in its own axis. So it will have this spin and this spin. So that is the best analogy that we can grasp, but please take note that this analogy fails because the angular momentum and the spin angular momentum, we call it now spin angular momentum, is very fundamentally quantum mechanical. So this is just a way for us to picture in our classical minds. Okay, so now we introduce our spin quantum number, which arises from the additional motion proposed by these two brilliant physicists. So this is our electron spin, and it is governed by our spin quantum number. So just like the angular momentum quantum number, or the z component of the angular momentum quantum number, we have Sz equals plus minus half integer of h bar. So this is the components of our spin angular momentum. And our spin quantum numbers are positive 1/2 for spin up. So if the electron is moving in this manner, it will have a spin up, and spin down. Minus 1/2 for spin down. So if the electron is moving in this manner, it will have a spin down. So I want to reiterate, these are just analogies. This is not what is fundamentally happening in the quantum realm. Okay, so now we have our complete set of quantum numbers. So let's just complete our list. So 1, we have the principal quantum number, and 2, we have our orbital angular momentum quantum number, L. 3, we have our orbital magnetic quantum number, denoted by ML, and lastly our spin quantum number, by MS.